So good morning to all. A warm welcome to all the participants of a day 2 session in the AST sponsored faculty development program on design thinking organized by Department of Mechanical Engineering, Sri Manakula Engineering College. I invite Dr. G.G. Soramanan, Professor, Department of Mechanical Engineering, to introduce our speaker, Dr. Rajesh Ranganathan.
Good morning to all of you. It is my great pleasure to introduce Dr. Rajesh Ranganathan, a special guest from Coimbatore Institute of Technology, Coimbatore. Dr. Rajesh Ranganathan, working as a professor in Department of Mechanical Engineering, CIT Coimbatore, and also he holds director for the Center of Excellence in Manufacturing Science Center. It is funded by the MHRD Government of India. Dr. Rajesh Ranganathan is obtained his doctorate degree in the field of additive manufacturing engineering from Lalborg University, UK. He is hold 6 patents and is published more than 50 journals in the reputed publications, and also is published one textbook. He is guided 10 PhD scholars and is currently guiding 6 PhD scholars. He is hold more than 6 crores funded project under his hands, and also 2 senior research associates working under his guidance. Dr. Rajesh Ranganathan is received Young Scientist Award from the DST for his working on diabetic food management services. Dr. Rajesh Ranganathan is worked before in the oil and gas industry in Aberdeen, Scotland, UK, before joining his in teaching field. Dr. Rajesh Ranganathan sir is going to share with us his expert opinion on design thinking and novel products through auditing manufacturing process. So I request you all the participants kindly participate the full session, and it will is very useful for you in the additive manufacturing process. Thank you. It's a time to hand over our special guest Rajesh Ranganathan sir. Thank you, sir.
And thank you, sir. Thanks for your kind introduction. And I thank you for giving me this opportunity. I thank Dr. Tyagarajan, Associate Professor, for giving me this opportunity. And I welcome one and all for the session. Thank you. Like, I just wanted to make sure, is my screen completely visible to every one of you?
Sir, we are getting your presentation, sir.
Okay, sir.
So your audio is clear, sir.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you.
Like, I'm ready whenever you're fine to go for it. Shall we start the presentation, sir?
Yes, sir. Yes, sir. Yes, sir.
Okay. A very good morning once again. Like, it's a quite a very interesting topic. What have been coined in this FDP program, design thinking, because now that the buzzword is innovation is the buzzword what everyone speaks. And I was reading about some articles, and it clearly pointed out innovation becomes zero, or innovation isn't useful if you don't put in design thinking or feasibility of use on any product. Like, across globe, every day thousands of products are being innovated, but it doesn't come to market. Not every product comes into market. And analyzing the failures of it, like very recently there were continuous reports by McKinsey about it, mentioning very clearly, like, innovation doesn't sustain without design thinking or applicability going into it. So it's quite an interesting topic which was being coined out, and I'm happy to be here for this. So, speaking about design thinking, what design thinking is, like, it is an aspect of solving a complex problem in a user-centric way and achieving a practical result. Fine. So let us think of a simple example. We all are somewhere or other we come across a situation of booking a hotel, and maybe a couple of years before, when it comes to the situation of booking a hotel, we know the mess that it used to be. Like, we need to call to the reception, we need to check the rooms availability, and even if we confirm it, there might be some communication lag. We can't compare the hotels. We don't know whether we are very close to the hotel, to the place where we want to go. So there are so much of complexities which tend to come in, even in a simple process of looking for an accommodation for a day. But like that went on a different approach, an approach of design thinking went in. So people thought, why not we go for automation, or apply internet for this. And I was so surprised to see that much of a design thinking went inside, wherein they made it in such a way it is user centric way, or we can put it down in that manner. Like, they completely designed it looking at what would the user want. The first thing user wants to compare the prices. They want to know how close it is to the nearest amenities, or you pick and choose what you want. Are you looking for a location in mid of the town, or what it is that you're looking for? So it is completely designed for a user-centric way, or else in a way customer was seen first, and then only the business was seen as a secondary one. So that's how design thinking completely changed the focus from design to design thinking. So when it comes to design thinking, customer was put in first, and then came the manufacturer, or then came the giver as compared to the taker. So that was a quite interesting thing which I came across. And to go bit in detail, or to speak bit explicit on design thinking.
Design thinking is a five-step process to come up with meaningful ideas that solve real problems for a particular group of people. The process is taught in top design and business schools around the world. It has brought many businesses lots of happy customers and helped entrepreneurs from all around the world to solve problems with innovative new solutions. Step 1. Empathize. The purpose of step 1 is to conduct interviews that give you an idea about what people really care about. We need to empathize with their situation. For example, if you want to help old people, you might find that they want to keep the ability to walk around. In your conversations, they might share with you different ways they can do that. Later into the interview, you'll want to dig a little deeper, look for personal stories or situations where things became difficult. Ideally, you redo the process with many people with the same problem. Step 2. Define the problem. Looking at the interviews, you can now understand the actual needs that people are trying to fulfill with certain activities. One way to do that is to underline the verbs or activities that the people mentioned when talking about their problems, like going for a walk, meeting old friends for tea, or simply going grocery shopping around the corner store. You might realize it's not so much about going out, but more about staying in touch. After your analysis, formulate a problem statement. Some elderly are afraid to be lonely. They want to stay connected. Step 3. Ideate. Now focus only on the problem statement and come up with ideas that solve the problem. The point is not to get a perfect idea, but rather to come up with many ideas, like unique virtual reality experiences, senior-friendly hoverboards, or a modified pushcart. Whatever it is, sketch up your best ideas and show them to the people you are trying to help, so you can get their feedback. Step 4. Prototype. Now take a moment to reflect on what you have learned from your conversations about the different ideas. Ask yourself, how does your idea fit in the context of people's actual lives? Your solution could be a combination of a new idea and what is already being used. Then connect the dots, sketch up your final solution, and go build a real prototype that's just good enough to be tested. Step 5. Test. Now test your prototype with actual users. Don't defend your idea in case people don't like it. The point is to learn what works and what didn't. So any feedback is great. Then go back to ideation or prototyping and apply your learning. Repeat the process until you have a prototype that works and solves the real problem. Now you are ready to change the world or open shop. To experience design thinking firsthand, do the free virtual design thinking crash course from Stanford Design.
So when it comes to design thinking, yes, it's a five-stage process, and undergoing the five-stage process, it not necessarily it means that you might end up improving a product. You might end up innovating a new product as well. So that is also the alternative door that design thinking tends to open up. We can speak of n number of examples on this, but there is yet another possibility for that as well. One example that we can speak immediately is like we all know the PDAs. PDAs first came into existence. The idea of PDA was coined by Apple, and when they coined it, they called it the Newton device. And this device, they made it in such a way that they understood the need for a PDA. They understood uh, why it is essential. It will be easy for. They brought up so many advantages of it, and they also thought to an extent of inputting the data into the PDAs, and they also moved to a stage wherein you can interface a keyboard with it, and you can put in key in whatever you need to feed in your PDA. So they went to such an extent, and when they were just to launch the product, they faced failures in terms of launching the product or getting the product into the market. And then was the time that Apple thought of an option like, yes, I did my innovation, but did I do a design thinking into it? So they looked into the three widely spoken areas in design thinking, that is studying the feasibility, understanding the viability, and see how it can be made into use in terms of the human values. So everything was thought of and innovation was brought in, and still the product was not getting into the market, or still they found the difficulty in getting the product into the market. And that, as design thinking was brought in, and suddenly everything got changed within the system of Apple, wherein they thought that rather launching the PDAs, they went for iMac. They started producing desktop computers. That was they completely changed from one product to another product, which they didn't even think of. But that was a success story wherein it clearly indicates that not necessarily when we start applying design thinking, we might end up refining one product. We might also end up coming out with a completely new product. So that's in a way. And if we speak of design thinking, there are three major parameters or three major lines that we need to touch on. One is design to design thinking, wherein designers traditionally we want to get a product done. So that falls under the category of design. And the first thing that need to be thought of is move from design to design thinking. And then, as was mentioned earlier, it is more of a consumer market rather the manufacturer market. And we all know that that is why Industry 4.0 is also heading. It is more focused to the consumer rather the manufacturer. So design thinking opens up an option of putting the consumer into participation, that is customer involved in manufacturing, or even the customer involved in designing the process itself. And it clearly states that you need to create the choices rather constraining the choices. Speaking of which, I thought we have a discussion on a couple of local examples. Design to design thinking. When it comes to design to design thinking, yes, we all know about this particular product, the very renowned Goli soda, which was there ages before the first product which came into market, and people loved it, and it had its own complexities. The main complexity was distribution of the product, getting back the product, and consumer, in spite of consumer liking this product, quality of product is good, everything was good, but only problem is how are we going to get the bottles back. The consumer need to consume it there itself in front of the shop before he moves out. So there were some intricacies which was involved in it. But as such, the design of the product is fantastic. The product was good. Everything was good. And they were the first people to market who came in, who brought the idea of, yes, you can have a ready-made drink which is available for you. So that was that. And then came design thinking into it, um, which was way ages after that. And we all know that there came a new product which came into existence, because one of the major problem with this particular product was getting the container back was a problem. And that is where design to design thinking came in, wherein from here we move to here. So it goes with all the same concept, but only thing is the container got changed, and this started giving ease of use. And um, I'm sure the product market is picking up back again. People started going back to this particular product. So that is in a way which is happening. And moving to the second perspective, consumption to participation, like a customer who is looking for a house. Yes, he would like to build a house. He fixes a house. He has his own design. He speaks to a civil engineer. He gets his house built. But as days started passing, this is not what the consumer was looking for. So, along with this, consumers started looking into aesthetics. So, he started getting involved with the civil engineer. And that's where architecture came in. And they were looking at the same house, maybe the same cost of house was built in a different profile. And again, it is costing bit cheaper as compared to whatever it was earlier in terms of continual use. In terms of long time use, it started becoming cheaper as compared to what it was earlier. So consumption to participation or consumer participation is happening slowly but in different places. So we spoke about creating choices. In the traditional method, when we were trying to make a design for a particular product, let us say we want to design a bottle, water bottle. So we narrow down from many, we take many designs and we tend to narrow down and we make one final design of a bottle. But with design thinking option, the entire approach of design changes here, only having one thing in mind, that what is the purpose. Purpose is taken care of, but the choices were opened up and the ideas were being fiddled around in order to make up a wider approach in terms of getting a product. And when it comes to a situation like all these examples, whatever we have seen, starting from the house to creating choices, then we are speaking of widening the product range, which is coming up. Like if we all these points, whatever we discuss, it all looks in terms of widening the product range. Let us say the traditional coffee cup, the straightforward coffee mug, given an option to redesign or design think it. Yes, people open up many designs of like this which can pop up. So creating all these designs, yes, the designs can be created, but can we manufacture it? That becomes one of the major questions. And alternatively, when we are speaking of putting the consumer inside the participation and making a product out, it, already exotic car manufacturers started doing this, wherein they started involving the consumer virtually, and consumer participation was brought in, and then they try to manufacture the part product, and then they are trying to give it to the consumer. Yes, this is already happening, but in a very small range. But there is some limitation which is limiting it to go wider. So that is another thing which is happening. And when customers given a choice to create options, like if we take 100 customers and if we ask all the 100 customers to pick and choose their own product, yes, it would definitely lead to 80 different products for sure. So that means that our traditional manufacturing system won't be in a position to support manufacturing 80 different products for one single purpose. So that becomes a limitation. So design thinking have opened up, but the limitation was stuck in one region, wherein in terms of manufacturing, how are we going to manufacture? Because the traditional manufacturing system is more of a subtractive manufacturing system, wherein you take a bulk, from the bulk you reduce, and you tend to get your final end product. Whereas this traditional system wouldn't be sufficient enough, because this traditional system would be perfectly, or it was sufficient enough when the market was in the hands of the manufacturers, wherein the manufacturer tend to produce a product and he tends to push the product into the market. But now it is more of a consumer driven market, where the customers demand the products, and technologies like design thinking coming along with it, the demand by the consumer is going up as compared to earlier situation. And subtractive manufacturing system wouldn't be in a position to substantiate or withstand this particular situation. And the only alternative, which was seen by many people, is additive manufacturing, wherein you take the raw material comes in maybe a wireframe model, or a wire model, or a solid model, or in a liquid form. The raw material is taken in a neutral form. All these forms are neutral forms, and from that neutral form, any complex profile is manufactured by adding layer over layer to get that final end product. So, so that is where the moment the shift started from manufacturer to consumer, the need is the shift from subtractive to additive, and this is taking place slowly. And speaking of additive manufacturing, and as being introduced, like I work specifically in the area of additive manufacturing. To just give a slight hint of what I do and knit up things. So I work predominantly in the area of, or the research focuses in supply chain and additive manufacturing. So combining supply chain and additive manufacturing along with the design thinking perspective, we tend to see how better we can produce products. um, because the moment we speak of design thinking, it is nothing but it's pure customization, producing parts, very innovative parts or unique parts for individual customer needs. So that is where customization comes in. And the parts can be simple in profile, complex in profile, because the moment we speak of complexity, the traditional manufacturing can't do it, whereas additive manufacturing can do it. So that is why we look in complex profiles, high accurate parts, and saying that I'm going to produce one of a product, or I'm going to produce a custom product. I can't take much of a lead time. I should be in a position to give the product to the customer within a stipulated time. I can't make the customer to wait for a longer time. So thereby lead time of product manufacture becomes an essential thing. And integrating from supply chain perspective, we can explore into n number of products into this, but our focus is mainly on healthcare domain. And again, within healthcare domain, we have certain limitations. And in terms of additive manufacturing, the technology that we use is an FDM and a polyjet printing technology. So this is one of the polyjet printing technology machine that we use. And to give a slight outline of what the potential of this is.
Comics uses inkjet printing technology that can jet two materials at the same time. This allows you to produce models containing a whole range of material properties to more accurately represent your final product. Each layer of resin is just 16 microns thick. It can even mix two materials to create a whole selection of properties, such as this material, which is tough enough to simulate ABS-like engineering plastics in applications such as this, or even this, that can do this. With Object's 3D printing technology, you can take your design idea and rapidly transform it into a functioning prototype. And you can do this with all the subtle details of your intended product built in, including the different material properties of assembled goods, such as this part. Multi-material technology is that you can build up to 14 different material properties, textures, and shades into a single part in a single print job. Object has an incredible range of over 60 materials, from rubber to transparent to engineering plastics, with the ability to mix and match various combinations.
So that's about the technology that we use at the moment. Ideally, the machine, in simple terms, we can say that it is a combination of a stereolithography, a selective laser sintering, and a 3D printer. So all these three combinations fall within this particular thermojet printing option. So this is the one that we use for much of our application in terms of developing the products. Um, the reason why I showed this product as an example is like you can print a rubber-like part, you can print a hard ABS part, and you can also print a glass-like part, maybe a polycarbonate one. And all these three combinations are possible in one single go. So that means that it opens up a very wide range of product possibilities, because here when it comes to customization we are looking at a very wider range of product possibilities. So that is where we adopt this particular technology. On top of it, even the rubber parts, we can pick and choose the show hardness values. Ideally, the elasticity levels of rubber can be changed. Like we can print a part with a, let us say that I want this part to be with show hardness of 20, while I want this to be show hardness of 80. I can print this key to a show hardness of 60, or this one to a show hardness of 50. So while printing itself, I can change the show hardness, though it's an rubber based product. I can still change the show hardness levels of these rubber parts along with these wider combinations, and I can still print the parts. So that was one major advantage of this particular technology. And when I speak about applications, we'll be discussing how we are using this varying levels of show hardness in practical application. So when it prints, as shown in that short demo, it now has two material combinations like material A and material B. And combining material A and material B, still we can create a secondary material. And in total, we can go for making a combination of 154 material combinations using 16 major materials. So that is quite possible with this particular technology. So it ideally has a primary material and it has a secondary material, and combining the primary and secondary, we can still produce a third set of material which are called the digital material. And this is where we find a wider application for this. Some of the possible examples, like traditionally, this we can only manufacture in a stereolithography, but that is possible in this technology. The one that is possible with SLS, it's also possible here. And one major combination wherein we are looking at rubber-based products. Earlier, we need to manufacture the rubber-based product separately, and then we need to glue it with a part that we are trying to produce it. But here, it is not necessary. Like all the products can be printed in one single go, so which opens up a very wider possibility to look in for. So giving a slight idea of what additive manufacturing technology that we use for this application, like let me go into the application side. As I mentioned, like combining supply chain management and additive manufacturing as a whole, like we explore into healthcare as one of the option. And healthcare domain is, again, it's a very big one, and within that we don't touch on all the product lines. We specifically concentrate on prosthesis, and wherein prosthesis is again categorized as internal and external. What internal is anything that goes inside the body, falls under the category of internal prosthesis, wherein it would be mostly the metallic parts. On the other hand, it's all the plastic, the metal parts which goes inside the body. Whereas on the other hand, anything that goes outside the body are called as the external prosthesis, and mostly the external prosthesis parts are of plastic in nature. So we completely deal with the external prosthesis, and on top of it, it limits the regulations as compared to, in terms of research, as compared to working anything inside the body, working outside the body is easier. So we work on the external prosthesis side. So speaking of that, let me go through a couple of case studies, and that opens up idea of how additive manufacturing was used for customer-centric application, how design thinking went into it, and how we are not speaking all these examples. Whatever I'm going to speak is not a mass production one. It is meant for one individual person for one period of time. Maybe if you're producing a component for person X, he can only use this part, and for Y it is a completely change in design of a part. So it keeps on changing from person to person. These products tend to change. Let us go through some examples. Like if we imagine putting chewing gum in our mouth and trying to um, have a snack, even a biscuit, it is not an easy job, because already we are having something in our mouth, and eating something else is not an easy job, and we know how complex it is. If having a chewing gum and inside your mouth and eating your own food is tedious, then let us think of a situation wherein having a brace, a dental brace, and chewing our food or eating our food. It's not an easy job. It is. It has its own complexity, and people who went through this, they can very clearly understand this. So this is where we thought we'll start with this. So we clearly empathized what is it. So we identified one situation wherein putting something in your mouth and chewing your food is not an easy task. Then how about the situation for people who are wearing braces for a period of maybe like 6 months or 1 year, and them chewing the food, them processing their food? um, it is not an easy task. It has its own complexity. So taking that, we went through a design thinking process, and taking that as a product, we try to empathize it. We try to explore further into it, wherein in terms of we try to understand what is the process that is happening behind. So going back to the process, this particular technology of putting the braces is not, though it got refined in 1900s or somewhere in 1920s, it got its refinement, but it moved way back from 1400s, wherein this was one of the crudest way, and the only refinement that it went on is, like, from here they moved to a better mechanical brace, the, where this particular requirement went through. Initially they started with braces, drilling the tooth and putting the braces, and external braces were tried by so many French um, maxillofacial surgeons or orthotists and dentists, and still that was not successful. So they came to realize that external braces are not going to support, and then came a situation where in early 1900s, with mechanical industries or industries picking up, like they tried for an option, and the one possibility that it went on is the mechanical braces. And this mechanical braces, yes, there were some advancements which came in self-aligning braces, and you can still adjust the braces a bit here and there. Fine tuning can be done, but still it is nothing but you're still putting something in your mouth, and it is not an easy job to think of. And you need to live with it for maybe 6 to 1 year. Some people even go for 2 years with the braces. And wearing a brace is not, it has its own disadvantages. Cleaning, yes, it's a difficult thing. And on top of it, the braces, tightening of braces, it leads to more amount of cracks in the tooth. And on top of it, it also tends to create more of a cavity because cleaning is not done properly. And that means that the dental problem is prolonging. It didn't get stopped over there. It is a prolonging process which was happening. And looking at this, yes, there are some alternatives which got launched in past couple of years, and some of the recent advancements that it got launched was the dental braces, which are otherwise called as clear tooth aligners. What clear tooth aligners is, like, you tend to have these um, polycarbonate aligners. You can put it overnight, and morning you can remove it off and you can get on with your regular job. Because the dentist claim that if you are able to wear an aligner for 8 hours continuously, that itself is more than enough in a day in order to align the tooth. And they suggest that when the tooth is trying to realign it, it is better um, we don't give much of an activity. So night times wearing this is found to be a better option as compared to wearing the aligner throughout the day. But we can't remove the aligner now and then, and we can't replace it. So removing and replacing with the traditional mechanical aligner is not a possibility. So that is where innovation went in, and they brought in this dental aligner, the clear tooth aligner, wherein the customer or he or she can just wear it during night and can doze off, and morning they can just remove it off and they can go ahead with their regular activity. So this was seen as an alternative. We were Once we saw this, we thought, okay, there is a way forward. And this particular process was quite expensive at the moment. And we tried to explore how this is happening, because in design thinking we go in 5 stages. So we made sure we passed through the stages in further. We empathize the problem, we define the problem. Now we need to go further in depth into the problem to explore further. So moving further, we try to explore what is the current manufacturing practice that has been adopted. Looking at the current manufacturing practice, a patient, when he goes to the dentist, he's been given wax mold, and he or she need to bite this wax mold and sit idle for 20 minutes. And when they sit idle for 20 minutes, obviously the imprint has been produced from this negative mold. Using plaster of Paris, they make a positive mold, and creating a positive mold, then comes the process of vacuum die casting, wherein dental aligner sheets, biomaterial based dental aligner sheets of thickness of which ranges from 0.5 mm to 1.25 mm thickness sheets are placed over, and vacuum molding is carried out. And once vacuum molding is done, the remaining portion, like this is what this is how the sheet looks. And they place this negative mold, and vacuum molding is carried out. So it tends to take the profile, and once the profile is achieved, using scissors manually, this portion has been cut off. And the portion that has been cut off, the profile for the mouth, or it has been cut off, and the part is ready for application. This usually takes, let us say, the patient goes by today evening by 7 o'clock. Maybe the part will be, they'll take a negative impression, and the part will be ready by um, next day, and the day after the part has been delivered. So this is the process that tends to happen. And one interesting thing is, like, everything depends on this negative imprint which gets created, and we need to sit holding it for continuous 20 minutes. Like, sitting and holding it for continuous 20 minutes is not an easy job, number one. And number two is, our human body is designed in such a way that every 30 seconds whatever we try to hold ourselves, we tend to move slightly. So when we start moving our body, that itself will start creating an impression. A clearance will start getting created every 30 seconds that we are there. This I'm speaking at a maximum stage, but we might move. People tend to move from for every 15 seconds to 30 seconds is the time that we tend to move, but definitely people tend to move. So when we sit for 20 minutes continuously, you can imagine the clearance amount that it tends to create. And end of the day, like if you are looking at 100% accuracy, after 20 minutes, what we get straight away is roughly about 60% accuracy that we tend to get. And once we have that accuracy level and creating a negative mold from there, it's not an easy job. Uh, yes, please. Somebody have raised their hand. Mr. Shyam Sundar. Um, any questions? Okay. Um, right. So it is not an easy job. So it has its own complexity to go for. On top of it, when it is being cut by scissors, definitely it is not going to give a custom fit because you need to have much of a convenience, else the bleeding of the gums will start occurring if we have sharp edges over here. Yes, they tend to slightly file it, but still the sharp edges are not being removed because the profile entire mouth's inner profile is not known clearly. So that itself is a complexity of its own. Yes, this process of clear tooth aligner is a way forward, but still it had its own complexity. So that is what we analyzed when we digged in further. So now came to the situation of yes, we went through all these first three stages. Now we also understood the existing system, and then we thought of coming out with our own idea and trying to create a prototype. And that is when we are in now in this particular case example. Going back to it a bit, like what dentists generally do is, let us say that they want to align this tooth. In that situation, what they would generally do is they would take these two tooths as a reference because these are the better tooths and these are the rigid tooths. So they take these two tooths as a reference and then they tend to align this. So once they align this, then they will start working on the rest of the tooths. So ideally what happens is within the mouth, one set of tooth being taken as a reference, or alternatively, they will take these three tooths as a reference and then they will align this first and then they will start realigning the tooths over this side. So that's how they tend to do the alignment. And one very important factor is, let us say that this tooth need to be tilted to an angle of 2 degrees and it need to be moved to approximately a distance of 1 mm from here. There is no measure to measure this particular process. We have measurements to a great extent wherein we can measure any mechanical object or any object for that means, but there is no measure to measure the human body measurements, or there is no measure to measure anything that is there in the dental area. We can't it all goes with an IU approximation. Now you can't say that I have tilted it to 2 degree or 1.5 degree or 5 degrees. No, there is no measure for this. So that comes one of the major complexity, and this was quite an interesting thing when we looked in, because there is no measure to measure any of the human body parts. And this is why we thought, how can we use the technology? Because among the three components in design thinking, we need to see what is the technical feasibility into it. So that is why we brought in the technology into it. And when it comes to working on this particular case study, what we did is we took a scanner, the handheld scanner, the pen type scanners, and we used that scanner to take a scan of the dental image. So it hardly takes maximum of 3 minutes to scan an entire tooth profile. So taking a scan of entire tooth profile, now it is very clear from a timeline of 20 minutes, we got it reduced to 3 minutes. And refining it, if we don't find the data good enough for us, even we went for complete rescans, and there were situations wherein a matter of less than a minute we were able to capture an accurate set of data of the dental space. And once we got the accurate data, that means that the errors started getting less. So the lesser we scanned, quicker data we got. So automatically that gave us a clear idea that from 60% we have improved the quality of data that it came to us. From 60 it went up to, let us say, even if we try to approximate, we are there by 80%, which is a 20% improvement. And once after having this dental scan, we moved it to Geomagics. Once this data is there in Geomagics, now that we know what is the profile over here, and we have also captured the space of gums. So that means that the end product is made in such a way it is 100% customization, whereas in the previous case it has been, though it is a customization, it has been cut using scissors. If the person have left this mark open, so automatically the sharp edge from the aligner, it will start rupturing the gums over here, and it will start creating gum bleedings, and it has its own complication. But now with this data, we are able to clearly make the aligner. That is number one. And very importantly, now that we can tilt or turn the tooths to the exact degrees. Like with Geomagics, it is nothing but again yet another CAD platform wherein you can exactly measure what is the angle, what is the space that you want to give. It's all made possible, and we are in a position to do that, and we tend to realign the tooth. And finally, the more important one, in the traditional method of making clear tooth aligners, once if they have completed aligning these three tooth, then the patient need to come back, and they tend to take one more imprint of this thing, because these become as a reference, and with these as a reference, the rest of the tooth will be realigned. Whereas in the current situation, once we have this first scan, we know that based on this first scan only the tooths have been aligned. We don't need the patient at all. We can straight away, because the already the data is here with us. So based on this data, we keep realigning it, and only thing is we keep supplying the new product, the individually customized product to the patient. Well, all they need to do is after every 15 days they need to remove off the previous brace, and they can keep using the newer brace, because it works exactly to that accurate levels of what it is. And this is the refined data. So after refining the data, all we do is we tend to give an incremental value, maybe a zero. 0.5 mm or 0.625 mm, depending on the amount of alignment hardness that we require over here. So we tend to give this alignment profile. As I mentioned, the profile is fine cut in such a way that it doesn't even disturb the gums, or it is as perfect as it can be. And the aligner has been produced. This data goes into the 3D printing, and the part is printed using the same machine that I discussed. And this is the printed part in the tray with the actual material and the support material, a combination of both actual and support material. This is the part. You could see the fine curves that it went in, uh, as compared to the traditional sharp cut edges when you cut it in using a scissor. So the aligner is ready. Once the aligner is ready, as I mentioned, it has been shipped to the customer, and the customer can use it. After 15 days, we know that these tooths have been realigned, and then comes, without the customer interference at all, the another set of aligner is made, and it has been given. And we did happen to go for a publication in this. And for this particular project, we work with a couple of dentists around Coimbatore on this particular project. And that is one thing that we do along with design thinking in order to bring a product, a 100% custom product. And if you look at this, if you're taking 100 customers, all the 100 customers are given 100 different products, and not one product which is given to one customer lies the same for the second customer. That is very clear. And on top of it, every customer of this the of the 100 customers, every customer need to have at least 5 set of braces minimum. They will start with 2 set of braces and they go until 18 set of braces, the maximum. But on average it's about 5 set of braces. Minimum is 2, on average it is roughly about 5 set of braces. So even if we take it as 5 for 100 patients, we are speaking about 500 different products, which is not at all possible in the traditional method. And if you look at the complexities in traditional method, the mold-based method, you need to bring the customer in every time you need to do it, and accuracy is lost. But here, the customer, all they need to do is they need to come down only once in a time, and for the first time they get the data, and then the product is ready every time and then. So it does all a different option which has been given. And another option of creating choices, wherein in terms of design thinking, we spoke about in traditional design, it's all about convergence, whereas in terms of design thinking, we need to go for creation of choices. So speaking of creation of choices, I'll take you through yet another example, a case study. Like we might have seen diabetic patients, and we all know that like sometimes looking at a person, we can very easily say the moment we look at the shoes or the slippers, we can very easily say that they are diabetic, because though the diabetic people, they tend to wear those diabetic sandals or shoes. And we all have seen this, wherein it tends to be of different in shape, quite bulky, and it is not so aesthetic in nature. Uh, and for that reason, many of the diabetic patients, though they tend to have the foot problem, they avoid wearing it because they don't want themselves to be shown to others that they are diabetic. And that is one reason that they mostly tend to avoid it. On top of it, if you look at the diabetic patients, they start from the age of 50, and imagine a patient who is roughly about um, 68 to 70 years of age, and for him or her, wearing this sandal is not an easy job. Bending down, putting the foot in, and then tightening it up, practically it is not an easy job. It has its own complexity. Day to day living, they have their own complexity. One is, it is hard for them to wear, and secondly, it is aesthetically it is not so good, so people tend to avoid wearing this. So then we thought, why not we try exploring this one? So that is why we started exploring into diabetic foot, and seeing the potential of this particular area. Some of the data that we picked up, because it's all about understanding the base first and then getting into the problem. So that is why we try to explore further into it. And diabetes was seen to be the fourth leading cause of death. And by 2030, about 439 million people is projected to get affected because of diabetes. And India ranks very high in terms of diabetic population. And there were so many data which points out that for every 20 seconds a leg is lost in the world because of diabetes. And by 2030, India will be the country with more number of diabetic patients as compared to China and US, which would be followed after India. And across globe, this population is growing up rapidly. And if we ask to each one of us, we every one of us know somebody or other in our family circle who is diabetic. So that is one of a very predominant disease which is occurring. And so understanding this, And knowing that how we can change the design of this particular product, we started exploring further. So we, wherever there is a diabetic camp, and we integrated ourselves with diabetologists and endocrinologists in this particular domain. And wherever there are diabetic food camps, we tend to participate in there, and we tend to collect the survey-based data. And from there, we involved about 2,570 respondents, of which the male is 1,885 and rest the female population. And we try to collect the data from them. And one of the questions that we asked is, how often do they meet a diabetologist? And how many of them meet a diabetologist as compared to a general practitioner? So of this, we found so many interesting facts, like mostly the diabetic patients, they tend to go to the general practitioner rather going to the diabetologist or diabetes specialist as such. And on an average, they only meet once in 6 months, but that is not a case wherein we all know the complexity of diabetes. So our data started pulling a different perspective view on it. And among the survey that we conducted, 50% of the respondents were aged 15, above 56 years of age, and roughly about 64% of the population, they only meet the general practitioner as compared to the diabetologist itself. And of the entire population, 52% of the population had food-related problems. So in that case, we started splitting what are the diabetes related problems, and looking at it, we narrowed down to five major complications among us all: high blood pressure, food problems, neuropathy, and heart problems. Among this, we could find food problem. 26% of the patients tend to have food problems, and we also realized that when we ran the surveys, most of them who came for the camp were having some issues with the foot. Either they had an amputation in the foot, a finger has been removed, or a certain portion of their limb was removed, or some people had a complete amputation. So yes, food problem was found to be predominant across the entire sample population that we saw. And when it came to, so now that from diabetes we started narrowing it down, and we realized aesthetics of food products is not good, and people are reluctant, and food is found to be one of the major issues. And then we asked how many of them are aware of customized insoles, and 43% of the population were aware of it. 5% of the population didn't have a clue that such a thing existed, and 54% of the population never heard of the term customization for insoles. So speaking about the actual problem, what it happens within the diabetic patients, like if a patient is diabetic, the issue starts as diabetic neuropathy, wherein in terms of diabetic neuropathy, we might have heard from diabetic patients saying that they tend to have a tingling feeling in their foot, or the plantar surface of the foot, or they might have lost the senses of the foot. They tend to have a burning sensation of the foot. All these things tend to occur. So ideally, what happens over there is, when they are normal, their nerves are quite healthy, and the veins that tends to take blood is quite open. They tend to have a healthy blood flow. But the moment they become diabetic, the nerves and the veins tend to become so soft. If you touch the foot of any diabetic patient, you can sense it that their foot becomes very soft, and as the nerves and the veins become so softer, it tends to bulge, and as it bulges, it tends to get clogged off. And once it gets clogged off, the blood need to flow in and flow to the leg, and it need to go to the top of the head, but it gets stopped over there. It doesn't move as such. So the blood gets stopped over there, and as it gets stopped, what happens is the blood which is there at the limb, it doesn't go to the top. It starts creating gangrene, or pus starts forming over there. And we know that the stagnated water causes much of an issue as compared to the flowing water. The same applies for blood as well. The stagnated blood, it forms as a gangrene, and if it's left untreated, what happens is it ends up taking removing of that particular region itself. So that is one of the major issue that we realized, and these were some of the crude profiles which tends to occur for a diabetic patient. And the question comes like, okay, what is that a mechanical engineer has a role over here in terms of diabetology? So that is where we started looking into the basics of it. Let us take a certain amount of load, and let us take a surface, and it has a point load, and if we try to load it up, when we move this entire triangle, obviously because of the weight, it will start getting worn off at a very faster rate, because the entire load has been distributed to a point contact. Alternatively, if we try to improve the surface area of contact, the wear rate would be less and the load bearing ability would be better as the surface area of contact increases. So that is one simple logic which could be very easily found. And relating this to humans, like when a person is diabetic, let us consider he is weighing 90 kilos, and that means that theoretically 45 kilos need to get transferred to his left foot, 45 kilos need to get transferred to his right foot. But in this is the theoretical case, but in theory it need to get transferred equally, but it doesn't happen because our foot profile is different, and we only have some point contacts. Like there are only certain regions which has a contact, and there are certain regions which doesn't have a contact with the surface at all. So that means that the areas which have a point contact, that is the region where it is going to get loaded heavily as compared to the regions where there is no contact at all. And when this person becomes diabetic, as his foot becomes softer, and the regions where there are point contacts, high loads will get distributed, and that high load distribution areas will start closing or clogging the blood flow veins, and obviously blood will stop flowing. So that is what the clear scientific conclusion that we came along with discussing with the diabetologist. And it is very clear that our foot is not been the load distribution in foot is not happening in a proper way, because if that have happened, our left and right shoes won't wear at an improper rate. The wear rate should be a proper one. It should be one of equally on all the sides, but that doesn't happen. So that is a very clear indication that the load distribution from us is not happening the way it should be because of the foot profile at the bottom. And again, when it comes to load distribution, we undergo different activities, so which need to be considered. So it is very clear that the load distribution is not happening the way it is supposed to be. And looking at the food profile, we further try to explore the different types of food profile. And looking into the different types of food profile, there are every one of us fall within these three categories of foot. Either it would be a flat foot, or a normal arch, or a high arch. Flat foot people, ideally people who are very bulky or above the BMI levels, they would be, or in the critical stage of their BMI levels, they tend to have a flat foot, or sometimes children are born with the flat foot as well. And second category, normal arch. Most of us who are on an average weight, not bulky or not too thin, we fall under the category of normal arch, and this is otherwise called as an athletic foot. And usually the sports people or people who are very thin or well built, they tend to have a high arch foot, and this is how it looks like. So this gives a clear indication. By nature, our foot is not completely flat, so the surface area of contact is not there. So that means that the load distribution is not going to take place completely. So it is very obvious that it starts creating foot problems. So this, as the surface area of contact is not there, so definitely the wear rate is going to change, and it leads to foot problems. So that is one conclusion. And speaking of the loads, like we human beings, we tend to go across two different load situations. One is the static load where we stand, and other one the dynamic load when we walk, move around. We fall. It falls under the category of dynamic loading. So the foot need to be considered for two different types of loading, both static and dynamic loading. So now there came three different situations: static loading and dynamic loading. Surface area of contact became an issue, and load distribution or irregular wear rate started occurring. So these are three major issues which we came across. Yes, already in market there are some custom insoles that are available, which is there in the market, and some diabetic footwear are also available. But one thing with all these diabetic footwear and the existing custom insoles are, those are not custom manufactured. Those are um, just um, m- made to the size. It is not custom manufactured. All they do is they only check what is your foot size, and for that particular foot size, a person is being given one of these insoles. Here, the number one is they don't understand the profiles, which profile is the foot in. Among the three profiles, we fall under three because for each profile we need to have a different type of footwear. Number one, and number two is it is only looked in terms of size. Let us say, for example, I might be of size 8, my foot size might be 8. Um, the other person's foot size might be 8, but he might be very bulky. Third person foot size might be 8, but might have a flat foot. So it changes from person to person irrespective of the foot size. So that has not been considered. And the existing diabetic foot insoles are nothing but they are just given a cushion like surface, and those cushion like surfaces, they it is more or less like you walking on a bed. Yes, walking on a bed feels nice, but for longer run it doesn't help us in any way. Yeah, because we need to have a rigid surface in order to get stability, but that doesn't happen with these, because it is more or less like it only gives a comfort to the foot, but it doesn't do anything more than that. On top of it, these need to be replaced once in every 3 months, because once the profile of the foot has been taken, then you can't wear this footwear. So there is no customization that it happens over here, and we have seen through the actual situation that nothing have happened in terms of customization, but there are complexities which are involved based on the type of foot and based on loading. And speaking of the types of foot, and if we look at the choices, as I was mentioning to you, like if we consider these three people, their foot size might be size 7, but each one have a different type of activity which is not being considered. Each one has a different weight which is not considered. Each one might undergo a different static and dynamic loading which is not being considered. So those are some of the very essentially missing facts which need to be considered when it comes to it. And taking one individual person from a child to an adolescence, like somewhere by 20s or 22, he or she might get a proper footwear size. Like let us say, if this person achieves a size 8, after that, after that, his foot size won't be changing until his last day. It would remain the same, but his activities will start changing. But our footwear is not designed based on that. Now, here we might be very dynamic, active, and follows a sedentary life. So the size 8 footwear doesn't take um, all these roles into consideration. It stays the same. So this is one essential fact that which need to be considered. And another thing, very importantly, by the time that we are of age 5, we tend to take a pattern of walking, which is called as gait pattern. which is considered very essentially in the field of orthodontics. What gait pattern is? We tend to, each one of us have a separate walking style. Either we tend to lean towards the left and walk, either we tend to lean towards the right and walk. So that's our foot walking style. And this style, which we get at the age of 5, it remains with us throughout the lifespan, and that also need to be considered, because any footwear that has been designed without considering the walking style, it will start creating the orthotic problems after a later stage. So that also need to be considered. So this opens up many technical requirements. Yeah, along with the 4 major parameters that we looked in, we also need to consider the gait pattern and the ease of use. So this is very clear that it indicates that customization is one of the very critical requirement for a footwear, and existing situation, no customization is carried out. And it is very clear that we need to create choices. We need to go for a design thinking approach, wherein each customer need to be given a separate footwear, and still, even giving a separate footwear for every 1 year, our weights would change. On an average, our weights change for every 6 months. So considering our weight change, the footwear also need to change. So that opens up. Now if we are speaking of 100 people, all the 100 people different need 100 different types of footwear, which is very clear. We need to create the choices. Fine, there might be a question which might arise like, yes, my great grandfather or grandfathers, they never bothered about footwear. And why is that we are speaking about all these buzzwords, customization? Why is that we are speaking about footwear as a very essential thing? But, but we go back to it. Grandfathers or great grandfathers, they were into agriculture, and they tend to work in the fields barefoot. So when they were walking barefoot, the surface underneath them is not rock solid like what the surfaces that we are walking now. The surface tend to deform according to our foot shape and foot size. So that means that 100% loading was taking place, because the surface tend to deform underneath our foot, and they didn't have much of these issues. The surface area of contact was 100%, so load distribution was happening over there. Whereas in our current situation, we don't do this, and we only work on hard surfaces, and the surface that we are walking is not deforming. So that clearly indicates that the load distribution is a point load distribution. It is not an entire surface area of contact based distribution that is happening. So this opened up or gave a clear idea, yes, we are going in the right direction. And I spoke about gait cycle, and going a bit more scientifically on the gait cycle. When we are on a dynamic mode is when we walk or run. Only 60% of the time our foot is in contact with the surface. Rest 40% we are in swing phase or in air. So that means that loading is going to be high when it is in a dynamic situation, because only 60% we are in contact with the surface. So what we did for this particular case is, we analyzed and we realized that there is a stage we need to completely redesign this. We need to incorporate a design thinking in order to reframe this particular structure. So that is where we started collecting data, furthermore data in terms of footwear, and for this we used imprinter, which is called as a pressure platform. Ideally, this was used by orthopedicians. After operation, they wanted to see the gait cycle. So for that, they used this, and we took it for a different application. Um, the pressure platform, wherein the moment a person walks on this pressure platform, his pressure distribution is being clearly pointed out. Um, like what happens is, if we look at this particular person, he's a normal foot, and the pink regions are the regions with high pressure regions. The red regions are the ones after pink. Then comes yellow, then comes green, and then comes the light blue. And there are some black regions where the pressure distribution didn't even happen. And this region, the foot didn't even get contact with the surface. So what we need to do is, so the logic is very simple. Wherever there are high pressures, we need to offload the pressures, and wherever there are low pressures, we need to load the regions with the pressure zones. So this is what we thought would be a better option. So using this requirement, we take data of individual foot. Let us say for this particular person, when he is diabetic, and there were live cases wherein we realized, we predicted that, let's say for him the foot ulcer will start in this region, and our prediction went on right, and this is the place wherein after 6 months of time he came with foot ulcers. And that is ideally because of higher pressure points were there, and that is where the problem started creating. So once if we offload these pressure zones automatically, and when we unload these regions where the pressure is not there, automatically the surface area of contact will also improve, and the pressure distribution will also start getting neutralized. So that is what we tried to do end of the day. And you could find a line which is going here. This is nothing but it is called as a gate line. And when we customized the insoles, we made sure the gate line remains the same before and after wearing the custom insole. The reason is, if the gate line deviates, automatically it will start creating problem to the patient, and we have orthotic issues. And here you could see the foot has been measured, the pressure points has been measured, and after measuring it, we offloaded and onloaded the foot at different regions, and the part is 3D printed. And I mentioned to you that this machine has the capability to change the show hardness value. Under the circumstance, let us say that I need a show hardness of 40, wherein I need highest flexibility over here, but I don't need any show hardness over here. So I used to fix 90 show hardness over here, because I need to load this region and I need to offload the high pressure region. So this goes with the show hardness of 40, and this goes with the show hardness of 90. So the pressure distribution has been changed now from location to location. So within a foot, the within one single part, the pressure based on this particular person's pressure distribution, the entire loading and offloading starts happening. Maybe for another person, his highest pressure would distribution would be here. So for him, it would be a varied elasticity level over here, and a varied elasticity level over a different place. And the part is printed, and this is with the barefoot and this with the custom insole, the data comparison. You could see that on an average, roughly about 30%, the pressure got reduced. And here there are some regions wherein after putting the custom insole, the pressure increased. So that means that loading started taking place, and wherever there was a peak pressure, the peak pressure loads have been reduced, and loading started taking place. And the arch region, which was not loaded earlier, where there was no contact at all. Earlier it was zero pressure, and now it has been loaded with a certain pressure requirement. So some loading have happened over here. And we didn't stop there itself. We also went to the Ayurvedic one. We just wanted to make sure, from the Ayurvedic perspective also, it is perfectly fine. And undergoing this, even you can do a Google search and you will realize that our pancreas, the nerves of the pancreas gets connected only to this arch region. And this arch region is the one which is not in contact at the moment. And this being not in contact, it doesn't get activated at all. So because of poor activation, or the contact is not at all happening and there is no activation at all, obviously the functionality of pancreas gets reduced. So the insulin secretion starts decreasing over there. And when we start giving up activation points over here, automatically it will start improving the functionality of pancreas, and yes, it will start improving the um, insulin levels. So we are claiming that it is not that this product would reduce sugar. One thing it can do is it can prolong the issues in terms of food. If a person is expected to have a food problem in a matter of 2 years, wearing these custom insoles would extend their time from 2 years to 8 years. So it would extend the timeline. we can understand that if we try to, when we are fine, we don't realize the importance, but the moment we get hurt in our leg, the whole day we feel it is so complicated. So we can imagine a situation who undergoes an amputation and who can't proceed further for his lifetime, the difficulty that he faced. It's quite a crucial thing. So our solution through this approach, we are saying that it would extend the lifetime of the foot by relieving the pressure zones. And this is a comparison table with barefoot and custom insole. You could see earlier it was quite erratic, and peak pressure distribution is better as compared to the previous situation. And the surface area of contact earlier, which was 135 centimeters square, have got improved to 157.5, roughly about 15% improvement. So automatically, once the surface area of contact is high and the pressure distribution is taking place, obviously it would lead to reduced foot issues. So this is a comparison between of a normal foot, the foot example that I have shown, in barefoot and with a custom insole. So you could find the changes. The peak red pressure zones got disappeared, and the surface area of contact have improved. And this person, when he or she becomes diabetic, automatically the pressure distribution gets improved, and they would feel much more comfortable as compared to whatever it is at the current situation. And these are the data of pressure reduction in various stages. On average, roughly about 30% of pressure reduction have happened, and obviously the surface area have improved. And we did happen to apply for 2 international US patents and 2 Indian patents on this. And we do have a couple of publications. So now that it is very clear, all these 4 parameters have been touched, and end of the day, our thought is, doesn't matter whether a person is diabetic or non-diabetic, we need to be aware that we need to wear a custom footwear, or at least we need to make sure we are wearing the footwear according to the profile of our foot. One takeaway that I would like to straight away give you is, some people tend to wear very high heels, or there are some shoes with medium heel, and there are shoes with flat surfaces. Only flat foot people can wear shoes which are flat in surface. Normal large people shouldn't wear shoes or slippers which are very flat or with very high heel. Normal arch can wear shoes or slippers which has a small heel, and high arch people can only wear the high heel shoes. And any mismatch in this, now that we would feel comfortable when we are healthier, but as time passes, when our bones tend to become weak, it tends to create its own problem. And it is very essential that we need to stick to the foot profiles when we tend to pick and choose the thing. So that's about the various topics. Any questions, please? Like I still have one more. I thought I'll discuss about one more case study. It's nearly about 11:20, so I'm pretty much open for questions. And if we have time, we'll go with one more case study. Else, I would like to. I'm pretty much open for taking up questions. So ideally, I would say design thinking through additive manufacturing is already happening, wherein we discussed with the dental application and with the foot application. And at the moment, where there is a demand, it is happening. So I'm expecting soon it will be in various areas. And I'm pretty much open for questions.
Thank you, sir. Thank you for your excellent and very informative session.
Yeah, thank you, sir.
So mostly you have demonstrated the medical applications, especially in the field of dental and diabetes. Really, it was a very interesting, sir. Now
Thank
the
you,
session
sir.
is open for the participant. If you have any question, you can interact with our Resource person Dr. Rajesh Ranganathan.
And all these case studies that I discussed, it is like what we did in Coimbatore, and it's all live case studies that we worked. It is not that we have pulled out the data from other sources. It's the live case studies that we did. Yeah. Yes, please. I'm pretty much open for questions.
The
Please.
participant can unmute yourself and ask the questions. So if you feel any difficulty, you can post the question in the chat box.
Sir, very good morning, here Dr. Nilesh Avte.
Yes, sir. Very good morning, sir. Please.
Sir, I'm from GH Raisuni College of Engineering, Nagpur, as a coordinator, Center of Excellence, Creative Design.
Okay. Excellent,
So,
sir.
yeah, our institute is an autonomous institute in Maharashtra, and we are second in UTTR ranking all over India.
Fantastic, sir. Congratulations.
So we are developing during COVID-19 pandemic situation. We are developing a splitter, U-type, U-shape splitter for the IGMC Nagpur.
Okay.
And design is registered to the IPR, Intellectual Property Office, Delhi.
Okay.
So my and also we are in collaborate and in our college. Myself also co-in charge of the BETIC lab, Biotechnology Innovation Centers, IIT Bombay.
Yes,
So
sir.
we are working.
Right. I actually myself and we were trying to integrate with BETIC, and Dr. Ravi and myself
Yes.
to have an discussion. And because of COVID situation, we couldn't catch up further. So yes, we are. I'm pretty much aware of BETIC lab. I was there quite a couple of times. Yes, sir. Please go on.
Yes, sir. Sir, your work is so nice and so excellent work done by you, sir. It's a fantastic work done by you, because it's a so right. But I'm asking one question. We are also working on some of the ergonomic related problem. So myself also working on the Rula software. Shall we? It is applicable because you are working about the fruit related problem. So Rula can apply for the agro-based problem, because the shoulder, regarding to shoulder problem, we are solving some problem regarding to vibration create in the shoulder of the farmer. One of the
Sure, sir. Like actually, I had one more case study on laparoscopic surgery, wherein it only difference is you are speaking on the agricultural side, I'm speaking on laparoscopic side.
Okay.
Exactly, it's a ergonomic issue which is being focused on. Yes, sir. Definitely, you can use it over there. And ergonomics was not touched in agriculture to my knowledge, and that is one area which is quite very much looked in at the moment. And if you need anything regarding that, whatever we have learned, I'm pretty much happy to share with you.
No, because myself are so confused. So that's why during your entire presentation, I observed something. So that's why I'm asking question, because you are a person those give such kinds of solution to me. Also, we are working one of the Nagpur-based advanced dental clinic. We are tie up with them and working on most of the projects. So recently, we are working on the these kinds of root canal systems, root canal related problem, and zirconium tools we are developing for the implant.
Okay, excellent, sir.
So our two projects are currently we are work on these projects. Is this one of the company based to the American-based company also gives this problem to us, and through this advanced dental clinic, we try to resolve this problem and conducting testing on the CFD and ANSYS also.
Okay. That's an excellent work that you're heading up. One thing is, along with Rula, you also try to look in for integrate hand anthropometric data when you're doing the agriculture shoulder-based design, because
Yes.
anthropometric data doesn't go, dexterity data goes in. So that is one thing that you need to add on top of it, but that you need to add it separately only for your agriculture-based application.
Yes, if organizer give permission to you, shall I show 1 minute my 1 minute my photo to sir Rajesh sir?
Sir, my kind request.
Yes,
I'm
so
sure.
because
So
another
yeah,
participant also
yeah,
asking question
yeah.
to sir. So
Like,
otherwise, I personally discuss with this issue with you, sir.
yes, sir. Like we
Yes,
both
yes,
can personally discuss on this.
yes, yes,
I will
yes,
share
yes.
my contact details and email ID. Definitely, we
Yes.
can catch up.
Okay, okay, sir. Good, no problem, sir.
Thank
Thank
you,
you
sir.
very much. Thank you very much, sir.
Thanks for your understanding, sir. Yes, sir. Any other questions?
Sir, I am Gopi from JPR Engineering College, Chennai.
Yes, sir.
Your section is very excellent. And
Thank
I
you, sir.
have one more doubt, sir, that caliber you have said no, that for any caliber designs is available for the polio attack person, because a polio attack person, there will be a caliber is there, but they can use with the leg, but there is any technology is advanced technologies is came.
Are you speaking about the mechanical Michelin braces,
Yeah,
replacement of Michelin braces?
Yeah, sir.
And which is the parameter that you are looking for, sir? Abduction, adduction, inversion, eversion, plantar flexion, dorsiflexion. Because among the six, we came out with a solution wherein you don't need to have the braces at all, because the braces, existing Michelin braces, are like you need to have both the legs and both need to be tied together. Am I right, sir? Hello?
Yes, sir.
Like you are speaking about these braces, sir.
Yeah.
You are speaking about these braces and you're looking for a possible replacement.
Yeah.
And yes, we did come across a possible replacement, wherein in our case, we came across one kid. The existing braces will work only when you have both the limbs together, but the existing braces wouldn't work when the limbs are not there. So we came out with a solution of such a brace wherein you can do abduction, adduction, inversion, eversion, plantar flexion, and dorsiflexion. All the 6 movements can be done in this one single tool, sir. So yes,
Actually, sir, actually these things has been using for to those have be not having the leg. The accident they have removed one leg, they can be easily to fix. But in case in polio attack or anybody else, how they can be has used this particular instruments to be the alignments.
We have used these instruments for people with for polio attack. We haven't worked specifically on polio attack, but one thing that we are very sure is we worked on the next stage of the polio issue, wherein in terms of clubfoot, in terms of polio attack, what you need to do is you need to extend this transfemoral knee support. So along with the transfemoral knee support, we have also worked on the 6 degrees of freedom that it goes inside. So it is a combination of both the things, and you are asking for this one, sir. Yes, that is possible, and we did happen to develop a solution for this. There is one paper published by me on this. If you refer it, you have a solution which has been suggested. But as you have pointed out, all it needs is we need to add the strength in this region for polio attack. I'm not sure whether you're speaking about transtibial or transfemoral. Like I'm speaking for the case of transfemoral. For transfemoral, we need to give a strength over add-on strength over here, and along with that, we need to provide the 6 degrees of freedom. So yes, sir, it is possible to do that. And at the moment, we have a solution for transfemoral and the 6 degrees of freedom. Hello. And Dr. Gopi?
Gopi sir, are you available? Gopi sir?
I'm not sure, sir. I
I
think
think he left.
his connectivity issue. Any other questions, please?
Participant, if you have any question, you can personally contact with Dr. Rajesh Ranganathan sir for your future research.
Okay, sir.
So my kind request to all the participants, please fill the feedback form which is posted in the group in the chat box. So attendance is mandatory for getting the e-certificate. So kindly fill the feedback.
Sir, feedback form is not available. It's giving this site cannot be reached. There is no issue of internet connection, as somebody has put in the chat box. If the Zoom meeting is running, I don't think there is any internet connection issue. We request you to please check it at your end. That's a humble request. Thank you so much.
Okay, ma'am, we will check it.
We try to submit this form, but it's unable to log in. So if it is possible, so share on the WhatsApp
We
group.
will sort out the issues, sir. We will sort out the issues. So now I request, now you can try for your feedback form. Now we are just connected. You just try it once again.
Made some corrections. Still, it's
Okay.
email login capable. Mandatory number. When I put them.
Okay, sir. Okay. So thank you, Rajesh sir.
Thank you, sir. It's my pleasure. And thank you all. Thank you all for your patient listening. Thank you.
I request the participant to join the session 5 at 11:45 to 1:15 p.m. The same link which we have posted in the mail as well as WhatsApp group. So thank you.
Sir, this new link is also not working. Sorry, but it's not opening.
ஏன்னா இது காலேஜ் சேர்வர்ல இருந்து போட்டுருக்காங்க அதனால
Okay, sir. Thanks.
Hemant Kumar sir, it's unable to fill up this form. We tried to fill up this form, but it's not possible. It's not link not open, sir.
You can better to try some other user, sir.
Browser.
Anyway, we will post the form in WhatsApp group, sir. After sort out the issue, we will post in the Google.
Okay, sir. Thank you. Thank you.
Actually, the link, if you post it through your mobile, it's accepting, sir. It's if you are posting if you're trying to open the link through Google Form, it's having some issues. Right now, the issue is with Google browser, I think. something is error is going on with Google Chrome, I think.
Check பண்ணிங்க.
If you are using your mobile, it's accepting, sir. We are trying to find out what is the issue. We will soon try to rectify it, sir.
Okay.